Hello everyone, this is FRQ number 7. So, A asks to draw a free body diagram. So, this is the object, it's rotated a little like this. F of G points down, and F of N points this way. And AC and centripetal acceleration points straight to the center, which is left in this case. Should be lowercase. That's part A. So part B, MV agent theta. Okay. So we're looking for what we're looking for an expression where okay, so Fn x is the same thing as the centripetal force. We also know that F and x squared plus F squared is equal to Fn squared. So yeah. So that means that F and x squared is equal to F n squared minus Fny squared. And Fny is also equal to mg because Fny points up and mg points down, and the car stays at like the same height. So this is that. So it means that rad F n squared minus F n, and Fc is equal to mv squared over r. R is equal to h tan theta because r is here and h is here, so if you divide h by cosine and multiply by sine, you get here. So we squared both sides, so Fn squared minus Fny squared is equal to mv squared over r squared. Fny is the same thing as mg, so we can write Fn squared is, I'm gonna add Fny plus fny is the same thing as mg, so we wrote mg squared. And I square root that, so fn is equal to radical mv squared over h tan theta squared plus mg r became h tan theta, as I said before, and that's how you get fn. That's the function for fn. Okay, part C asks to derive fc function, so h so we know that fc is equal to fnx. Substitute fnx for mv squared over r, and then substitute r for h tan theta. And that's fc. Part D asks to derive v formula for v. So there's no friction. Wait, yeah, there's no friction for this one. So fc is equal to f and x fnx is the same thing as fn cosine theta. And then this is mg, fn is also the same thing as mg divided by sine, because mg sine is fny, which is mg, so the m's cancel out, and you multiply the r over. Also the cosine and sine, they make a cotangent, so bg cotan theta. The r is multiply the r over and substitute out for h tan theta. And tan and cotan cancel out because cotan is cosine over sine, tan is sine over cosine, and they both cancel out. So v squared is equal to gh, and that means that v is equal to radical gh. E asks to set up Bmax and Rg mu s and theta, so 7 x and y. So the x direction, f n x plus f s x. fxs is the it's a horizontal friction static, force of static, and that's equal to fc. And then in the y direction, the vertical contact force minus the vertical static friction is equal to Fg, which is the same thing as mg. So we can simplify this to f n y. It will be sine theta minus fsy, which is the same thing as f n mu s times cosine theta, because they use a different angle, and that's equal to mg. We can now factor out fn, so fn is equal to mg and we factor out fn, so we sine theta minus mu s cosine theta and you just divide that over, so f n is equal to mg over sine theta minus mu s cosine theta. But that's not the Vmax yet, so fnx is the same thing as fn cosine theta plus fn mu s sine theta, and that's equal to mv squared over r so we can factor fn out, and then now we substitute f we can substitute fn for mg over sine theta minus mu s cosine theta, so it will be times mg, and it will be divided by sine theta minus mu s cosine theta. And that's equal to mv squared over r. Now I can cancel out the m's, and I can now multiply the r, so it will be RG cosine theta plus mu s sine theta over sine theta minus mu s cosine theta is equal to v squared. This is v max squared, and I can square root it, which means that is equal to v max. And that's part E. Part F has to find minimum speed. So to do that, we set up x and y again, but this time fnx it's fnx minus fsx and fnx plus fsy. So in the y direction, be f and sine theta plus f and mu s cosine theta is equal to mg. You factor it. I'm just gonna copy and paste. But instead of minus mu s cosine theta, you add it and you divide it over, so we f n is equal to mg divided by sine theta plus mu s cosine theta, and fnx is I'll just copy and paste it because fn cosine theta plus mp squared over r, but it's minus this time. You factor fn out, then that you substitute the fn, the m's cancel out, and you multiply r over, and that's equal to v squared. This is v min squared actually. V squared root it. So this is equal to v min. Now for part G, we need to prove that f net is equal to that. So net force is equal to Fc. And net force is equal to mv squared over r. This is v max because that's how you get the largest force. So you sub in v max for this as we derived. So net force is equal to m over r times and it's squared. So that means that the square cancels with the square root. And this makes net force is equal to m r g cosine theta plus mu s sine theta divided by sine theta minus mu s cosine theta over r. So the r's cancel out. So we will be left with net force is equal to mg cosine theta plus mu s divided by so now that we have that, we can multiply everything by 1 over sine. We can multiply both sides by 1 over sine. So this being multiplied to this, it makes the sine cancel out, and it makes this cosine over sine, and it cancels out this sign. It makes it negative mu, or it'll be making it 1 actually. This will also be 1, it should be mu s. So net force is equal to mg. This is now cosine over sine, which is cotan theta plus mu s gets the sine cancelled out divided by the sines cancel out, so it'll be 1 and this will make it cotan. So 1 minus mu s cotan theta. And that's the same thing over here. We can make the m capital because that's how it's made in the how it is in the formula. Okay. Thank you for watching. Bye.